Hi, today we are solving problems on the topic of the law of universal gravitation, and let's look at the next example. In one hand you hold an apple of mass 0.11 kilograms, in the other hand you hold an orange of mass 0.24 kilograms. The apple and the orange are at a distance of 0.85 meters away. What is the force of gravity that the orange exerts on the apple and the apple exerts on the orange? Let's write down the terms of the problem, and in this case we have to calculate two forces. That is the gravitational force of these two objects, given that we know the mass of the apple. Let's denote it as mass 1, 0.11 kilograms. And the mass of the second object, 0.24 kilograms. And we know the distance between them is 0.85 meters. As we see in this problem, all data are presented in SI. That is, we will not translate anything, and let's immediately begin to solve this problem. For the figure we can use the standard scheme. That is, we have two objects with certain masses. There is a distance between these objects. In this case, of course, we mean the distance between their centers, taking into account that compared to the distance between the centers, the size of the objects themselves may be quite small. So we're treating these masses as point bodies, so we're neglecting the size of the objects themselves. So let's calculate the first force. Basically, we know that the force of attraction between two objects will be described by the law of universal gravitation. And we know the formula for calculating this law, so let's put a numerical value on it. Let me remind you that the gravitational constant has a value, this value, to the minus the 11th power. At dimensionality, we will not write, because all the data is already presented Fc. And using the known law, of course, at the end, we will get the power of measured newtons. Next, the mass of the first body, 0.11 kilograms. The mass of the second body is 0.24 kilograms. And we divide that by the square of the distance between the bodies, 0.85 squared. And in this case, the dimension will be the force in newtons. Once we've done the calculation, we get a force value of about 2.4 times 10 to the minus 12th power of a newton. So this is the value of the force with which an apple is attracted to an orange. And now the second question is with what force the orange is attracted to the apple. Of course, in this case, we remember that both of these bodies are attracted to each other with equal modulus, because Newton's third law says exactly that. So even from the formula, we can see that if we swap out on these two masses, the product of the two masses remains the same. So in this case, the second force that you and I asked for in this problem will also have a value of 2 and 4 times 10 to the minus 12th degree of Newton. Paying attention to the force itself, it turns out to be very small. That is, if we have an idea of how much it is, minus 12th degree Newton, that is, of course, it is impossible to measure it with ordinary scales. It's very difficult to detect these micro forces in nature. So, of course, in this case, we're saying that we can't detect this interaction in nature because of the smallness of the interaction. So in order for us to observe the interaction of such bodies, the masses of these bodies must be large enough. So we have solved the first problem. In the next lessons, we will continue to solve problems on this law. Goodbye.